Hello students. So in this lecture I am going to discuss 5 important questions which came in NEET exam. So first question, that is question number 8. The hydrolysis reaction that takes place at the slower rate among the following. So you see 4 options are given. Okay, 4 reactions are given and all these reactions are what the hydrolysis reactions. Okay, in which case what happened, the rate is slow. In question it has been asked what, in which case the reaction is slow, the rate of reaction or the speed of reaction is slow. So you look first reaction. Okay, you just try to compare all these 4 reactions, in which case reaction is not possible, that you have to find out. So look the option number 4, you look. Okay, so here aqueous sodium hydroxide, the role of aqueous sodium hydroxide is what, to produce OH minus as a nucleophile, and we know that this is what, a benzyl carbon. Okay, this carbon is what, the benzyl carbon, and what happened, this OH minus can easily attack to this carbon, and Cl is a good leaving group, so it can go away. Here what happened, it is what, benzyl carbon. This is the rate of reaction is a very high in this case, and this is what, allylic carbon. So hence what happened, the OH minus can easily attack here and the Cl group can easily go. And here the OH minus is what, all will undergo what, SN2 reaction mechanism. They will undergo what, SN2 mechanism. So here also the OH minus will attack to this carbon and the Cl will go. But look in this case what happened, here it is a benzene ring is present. Okay, so here benzene ring is present. Now in case of benzene ring is present, look here, one Cl group is present, here Cl group is present, and here one methyl group is present, CH3 group is present. Now when it react with aqueous sodium hydroxide, it is giving what, OH minus as a nucleophile. What it generate, OH minus as a nucleophile. Now you see this Cl group is present on the benzene ring. It is showing what, resonance it is showing what, partial double bond character. This bond is a very strong bond, hence what happened, the OH minus cannot able to attack to this carbon and cannot able to cleave this bond. Hence what happened, the OH minus cannot attack here, because this chlorine group is having lone pair of electron, and this lone pair of electron is in conjugation with this benzene ring. It is showing resonance, it is showing partial double bond character, hence the OH minus will not be able to cleave this bond, and hence what happened, it will not undergo reaction. Hence what, it will not undergo reaction, and hence what happened, the reaction rate is very slow in the option number 1. So hence the correct answer here is what, option number A. Now come to second question. The compound A on treatment with sodium gives B, and with PCl5 gives C, and B and C react together to give diethyl ether. So first of all, write down the data which is given in question. First it is given what, the compound A on treatment with sodium. A on treatment with sodium, what it will give? It will give what, B. Compound A on treatment with sodium, it will give B. And with PCl5, means A when reaction with PCl5, look on PCl5 it will form what, C. Now in given B and C, okay, B and C react together to give what, diethyl ether, means what, C2H5 OC2H5 it will form what, diethyl ether. So what you have to find out, you have to find out what is A, what is B, and what is C. Now come to the options which are given in A, B, C and D. Look here, the A is given alcohol here, here, here and here. So obviously you think that, okay, if you will take C2H5Cl with Na, then what happened, there will be no reaction. But if you will take A as a ethyl alcohol, and we know that ethyl alcohol react with sodium to form what, sodium ethoxide. Ethyl alcohol react with PCl5 to form what, ethyl chloride. Okay, so hence what happened, A is obviously what, ethanol. C2H5OH, this is what, A. Now this is C2H5OH when it react with sodium. Okay, so here A is what, ethanol, and when ethanol react with sodium, it will form what, sodium ethoxide. This is C2H5ONA, it will form sodium ethoxide. So this sodium ethoxide is what, B. And when this A react with the PCl5, this reaction also you know that this is a chlorinating agent. What happened? OH group is replaced by this Cl. Then what you will get? C2H5Cl you will get. Now this is C2H5Cl is what? C. Now what happened? B and C react together to give this one. Now this is which reaction? This is sodium alkoxide and this is what? Ethyl chloride. This is what? Williamson ether synthesis. What is this? This is what? Williamson ether synthesis. Now B is what? C2H5ONA. Now look, C2H5ONA, and when it react with C2H5Cl, okay, when it react with C2H5Cl, then what happened? SN2 reaction is taking place. SN2 reaction is taking place, and this reaction is called Williamson ether synthesis, and here it will form C2H5OC2H5. okay, C2H5OC2H5. This is called as what? Ether. So which option is correct? Option, look here, A is what? Ethanol, okay, B is what? Sodium ethoxide, okay, and C is what? Ethyl chloride. Hence option number D is correct. Hence option number D is correct. Now come to question number 10. Okay, in question number 10, what it is given? Look, here it is given C6H5CS2Br, benzyl bromide with magnesium ether. Okay, with magnesium in presence of ether in first step, and second step is what? Hydrolysis H3O plus. So first thing is what? This is the reaction of the preparation of what? Grignard's reagent. So there will be the insertion of magnesium atom in between carbon and Br. So look here, this is, so look here, C6H5CH2Br. So we can write like this. This is C6H5 and this is what? CH2Br, CH2Br. Now you look, the bond in between carbon and Br, what happened? Magnesium insertion reaction is taking place in presence of what? Ether. Ether here act as what? A solvent. So here what happened? This is C6H5CH2MgBr formation is taking place. This is CH2MgBr formation is taking place. Now look here, this carbon magnesium bond is what? A polar bond. This carbon magnesium bond is polar bond, and this is CH2 is del minus and this is del plus. Now when you will do what? Hydrolysis, then what happened? When you will do hydrolysis, this is H plus, okay, and this is OH minus. This is H plus and this is OH minus. So hence what happened? This, there will be the cleavage of this bond, and hence it will form what? C6H5CH2H means what? CH3. Look here, here it will form what? CH3. Here it will form CH2 and H means this is CH3. This is what? A toluene. So which option is correct? Look, this is option number C is correct answer. Here option number C is correct answer. Next come to question number 11. Question number 11, it is given what? Which of the following reaction is an example of nucleophilic substitution reaction? Look, option number A. Option number A is what? Given 2 molecules of Rx react with 2 molecules of sodium to give R, and R means this is a dimerization reaction, and this reaction is what? This is a name reaction called Wood's reaction, and this is not the example of a nucleophilic substitution. Now come to question next option, that is RxH2. So here this is a reduction reaction. There, this is not an example of what? Nucleophilic substitution reaction. And come to option number C, Rx plus of magnesium in presence of dry ether, it will form what? Grignard's reagent. This is one insertion reaction. But look, option number 4, alkyl halide react with potassium hydroxide, it is forming what? Alcohol. This is what? A nucleophilic substitution reaction in which OH minus act as a nucleophile, and we know that the alkyl halide bond is a polar bond, so the OH minus nucleophile can easily cleave alkyl halide bond, and hence it will form alcohol. So this is one example of what? Nucleophilic substitution reaction. This is one example of SN2 reaction mechanism. Hence option number D is correct. Now come to the last question. This is given what? Which of the following is not a chiral compound? Which of the following is not a chiral compound? So what is the criteria for a chiral compound? So which of the following is not a chiral compound? Okay, so option number 1, 2-hydroxypropanoic acid. Option number 2, 2-butanol. Option number C, 2,3-dibromopentane. Option number D, 3-bromopentane. So you look, out of these 4 options, you have to find out which one is not chiral. Which one is not chiral? Means which one is not optically active. We know that if a carbon is joined by a 4 different group, in such case we call that carbon as a chiral carbon, and that compound is called as optically active compound. So look here, first thing is what you have to do, you have to write the structure of all these 4 compounds, and if you will get the carbon, a single carbon which is having 4 different group, then that compound is called a chiral. That compound is called as what? Chiral compound, optically active compound. Now look, 2-hydroxypropanoic acid, it is consisting of a chiral carbon. A carbon which is having what? 4 different group. 2-hydroxypropanoic acid structure is like this. This is what? Propanoic acid. This is meth, and this is eth, and this is propanoic acid. Now 2-hydroxypropanoic acid means here will be OH group. Okay, here will be OH group, and here is what? Hydrogen, and here is methyl group. Now look, this carbon is called as what? A chiral carbon, because it is connected with the 4 different group. One is hydrogen, COH group, OH group, and CH3 group. So this is option A is what? A chiral. Option A is what? A chiral compound. But what you have to find out? You have to find out which one is not chiral. So now come to 2-butanol. Butanol formula is what? This is 1, this is 2, this is 3, this is 4. Okay, and butanol means position of OH group is what? Position of OH group will be 2, means here. Now look here, this is called as butan-2-ol. Now look here, this is what? CH3. This is what? CH3. Now look, this carbon is a chiral carbon or not? Because it is having 4 different group. This is ethyl group, this is CH3 group, this is OH group, and this is hydrogen group. Hence this is also a chiral carbon. But look, 2,3-dibromopentane. 2,3-dibromopentane, just draw the structure of 2,3-dibromopentane. This is pentane 1, 2, 3, 4, and 5. This is 2 and this is 3. 2,3-dibromopentane. 2,3-dibromopentane. Now look, this carbon is a chiral carbon or not? This carbon is a chiral carbon because it is having what? 4 different groups. Okay, this is called a chiral carbon. But now come to the last option, 3-bromopentane. 3-bromopentane. This is what? Pentane 1, 2, 3, 4, 5. Now this is what? 3-bromopentane. This is 1, 2, 3. 3-bromopentane. Now look, does this is a chiral carbon? Does this is any chiral carbon is present in this compound? No, chiral compound is not present. Why it is not present? Look here, here it is CH3 CH2 group, CH3 CH2 group. Both the groups are same group. This is what? Same group. Hence no chiral carbon. No chiral carbon is present. No chiral carbon. Hence this compound is not a chiral. So hence the answer will be what? Option number D. So this is what? Option number D. So thanks for watching my channel, SKS Chemistry.